So I wanted to show you this one just because for this one we have to figure out a pattern, and it's actually not too difficult. But let's take a look. The first thing that I noticed was, well, it's like 2, 4, 8, 16. Those look like squares to me. Like 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. That just comes with experience. You got to try a bunch. Good luck. And then also, actually, this would be over 1, so that's 2 to the 0. So my first thing that I would do is maybe say I'll start it at n equals 0 because I have 2 to the 0. So maybe my formula will have 2 to the n involved in it. And then this is n equals 1, n equals 2. That's one of the most useful things that you can do, is write down the n values. And then how do you get these numbers? Using this n value. That's what I'm going to do next. So there we go. Sometimes you can start it at 1 if you wanted to, and then just mess around with stuff. Then I have, what is this? 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4. Oh yeah. Is this 3 to the 5th? Yes, it is. So that would be 3 to the n and something. But here's a problem. This alternates, and I'm going to show you how to alternate sign. So first, let's figure out the bottom. That would be 2 to the n, because then I have 2 to the 0. That's 1. 2 to the 1 is 2. 2 to the 2 is 4, and so on. So that works out. Then I want 3 to the 1, but n is 0. How could I ever do that? Well, that's 3 to the n plus 1, because 0 plus 1 is 1. So it would be 3 to the 1. Perfect. And then 3, so I'm pretty much guessing and then checking. 3 to the 1 plus 1, that's 3 squared. Well, that's 9. And then 3 to the 3rd, there we go. So it works out, because 2 plus 1 is 3, and then that's 27. Now, how do I get the alternating signs? Well, that's also pretty easy. We can just multiply by -1 to, well, this one's positive. So if I made it to the nth power, -1 to the 0th power would give me a positive 1. -1 to the 1st power would give me a -1. Perfect. If it was like this, and it alternated a different way, then I can just say n plus 1 and it would shift it over. You should play around with that and see what works and what doesn't. But there's a formula that I can use, and I'm going to show you a little bit more for this because I think it's important. This is actually for like geometric series, but let's take a look. If we had, well, I'm going to use some exponent rules. 3 to the n times 3 to the 1. Remember, same base, you add exponents, so that's okay. And then times -1 to the n, I can do that. And 2 to the n. Now I notice that all of these are now raised to the n, so I'm going to combine them and then just have a 3 out front. 3, and then times, actually -3 over 2, because 3 times -1 is -3. And then I have an n on the outside. So there I go. I have my my a sub n now. I could actually rewrite this summation as the sum n equals 0, starts at 0, n equals 0 to infinity of 3 times -3 over 2, and we found out that this actually doesn't need to be 1. We can actually still use the nth term test for divergence. It won't change anything. So I'm just going to use it, and the limit as n approaches infinity of this. Ooh, this is interesting. This actually oscillates. It does not exist, which is not 0, right? If we have n being positive, then this becomes a positive number, and it grows. It just because this is bigger than 1. If it was smaller than 1, it would shrink. And then if n is odd, then this would be a negative number. So it oscillates. So this does not exist, but that is still not 0. So we can say diverges. And this actually diverges by 2 tests. And it diverges using geometric series tests. But there you go. If the limit doesn't exist, it's still not 0. So we can say that it diverges by the nth term test for divergence. Okay, I'm done.